Hello viewers, question 3, and we need to find the resultant force of the system that you see on screen there. We have a 23 Newton force pointing upwards, a 19 Newton force pointing rightwards, a 15 Newton force pointing downwards, and an 11 Newton force pointing leftwards. Those four forces in combination are the same as what one force acting in which direction. That's what we need to find out. So we need to decompose each of those forces into its horizontal and vertical components. We need to draw up our force horizontal and force vertical table. So we have our forces. We have the horizontal component down that middle column, and we have the vertical component down the last column. Let's start with the 23 Newton force. So the horizontal component of this force will be 0, since this is exactly a vertical force, so the horizontal component is 0. The vertical component is 23, and as it's pointing upwards, that's positive 23. Let's do the 19 Newton force pointing to the right now. So its horizontal component is 19, pointing to rightwards, so that is positive, and the vertical component is 0 because it's perfectly horizontal. We now have the 15 Newton force. Horizontal component will be 0 because it's pointing vertically, and the vertical component will be 15. This will be negative because it's pointing downwards. And we then have our last force, which is 11 newtons pointing leftwards. So its horizontal component is 11. As it is pointing to the left, that makes it negative, and the vertical component is 0 because this is a horizontal force. So let's work out the totals. So if we add up that horizontal column, we get 19 minus 11 is 8, and in the vertical direction we've got 23 minus 15, which is 8. So our totals are 8 in the horizontal direction and 8 in the vertical direction. Okay, so now we need to work out the overall magnitude of the force. Before we do that though, let's work out approximately what direction our resultant should be pointing in. We're getting a positive horizontal component, which means it's pointing to the right, and we're getting a positive vertical component, which means it's pointing upwards. So if we do our rough direction, we should get a force that's pointing upwards, rightwards. Let's work out its magnitude. We can do that by using Pythagoras on this right triangle. So we've got a horizontal component of 8 and a vertical component of 8. Therefore, if we use Pythagoras' theorem, we get f is the square root of 8 squared plus 8 squared, which turns out to be 11.3. So the resultant force has a size of 11.3 newtons. Now we need to work out its direction, so let's find an angle. Let's find the angle with respect to the horizontal. So theta is going to be, we know the opposite and the adjacent side of that triangle, so we are going to use tan. We're finding the angle, so we're using inverse tan, which is going to be of the opposite, which is 8, over the adjacent, which is also 8. Calculating that, we get 45 degrees. So our resultant is 11.3 newtons in the direction of a 45 degree angle upwards and to the right. Thanks for watching. Over and out.